In this video, we will discuss how we can calculate the molality in different cases. So, in this video, we will learn how we can relate the molality with other concentration term like percentage W by W, percentage W by V, capital M matlab molarity and mole fraction, etc. So, first of all, we should recall that what is molality. So, molality, as we have discussed earlier, that moles of solute in 1 kg of solvent. So it is to be remembered that moles of solute in 1 kg of solvent. So let's start with the first example, first case, in which 10% W by W annual solution is given. Again, 10% W by W annual solution means 10 gram of NaOH in 100 gram of solution. And to calculate the molality, it is required to find the mass of solvent. So how we can find out the moles of NaOH will be 10 by 40 into, you know that mass of solvent is required to calculate the molality, and the mass of solution is 100 gram and the mass of solute is 10 gram. So mass of solvent will be 100 minus 10, that will be 90 gram. So 10 by 40, which is 1 by 4 moles, and definitely it will be 100 upon 36, 100 upon 36, that will be equal to 25 by 9 m. This will be the molality of solution. In the second question, 10% W by V NaOH solution is given. So again, molality is moles of solute in 1 kg of solvent. So the number of moles will be 10 by 40. Now it is required to calculate the mass of solution. Mass of solution will be 1.2 into 100, which is 100 ml into density is 1.2 minus 10 gram into 1000. On solving this, you will get 1 by 4 moles, 1 by 4 moles into mass of solvent you will get is 110 gram into 1000. So on solving this, you will get 25 by 11 m. In the next question, it is given that 2 capital M NaOH. It means that the molarity of solution is given and the density of solution is given, and it is required to calculate the small m. Again, you will follow the same funda, that moles is given as 2m, and how you will decode the 2m NaOH solution, that 2 moles of NaOH present in 1000 ml of solution. So it is 2 moles. How we can calculate the moles mass of solvent? That will be V into D. V is 1000 into density is 1.2 gram. This is the mass of solution minus mass of solute, which will be 2m. 2 moles के according 80 gram होगा into 1000. Simply we can solve this, and we will get capital M is equals to 1.78. Sorry, small m is equals to 1.78. This will be the part third. Now aqueous solution of glucose with mole fraction 0.2 is given. So here we will use a very important concept that we discussed in the last video, that the ratio of mole fraction is in mole ratio. So definitely aqueous solution is given. So the mole fraction of solute and solvent will be mole fraction of glucose divided by mole fraction of H2O. Definitely it will be 0.2 divided by 0.8, that will be in the ratio of 1:4. So now we can calculate molality easily. You have 1 mole of solute and 4 moles of solvent. So the mass of solvent will be 4 into 18 into 1000. On solving this, you will get 250 upon 18, and 250 upon 18, this will make 13.88. So this will be the correct answer of this. So simply we are decoding the concepts, and we are using the simple definition of molality to solve all this problem. In the next question, it is given that I2 dissolved in benzene with mole fraction of I2 is 0.1. So it is to be noted that I2 is solute and the benzene is solvent. Simply again the ratio of mole fraction of solute and solvent will be in their mole ratio. So the mole fraction of I2 and mole fraction of benzene will be definitely 0.1 divided by 0.9. According to that, the ratio should be 1:9. So simply we can use the molality definition again. The moles of solute, which is 1, and the moles of solvent is 9, and it is required to calculate the mass of solvent. So we will multiply the molecular mass of benzene, which is 78. It is to be careful. The molality depends on the mass of solvent. So what solvent we are using, you must be careful. We can use water, liquid ammonia, benzene, etc. So when we will solve the fifth part, and you will get 250 by 18, that will be 13.88 m. In the next question, when you will solve this, you will get 1.42. And the next question, a solution prepared by ethanol and water in which mole fraction of ethanol is 0.9. Usually it is a misconception that we consider water as a solvent, and we usually mistake in the question. So it is to be noted that the ethanol mole fraction of ethanol is 0.9, so it is the major component of the solution. So ethanol will act as a solvent and water will act as a solute. So again, the ratio of solute, which is water, and ethanol, which is solvent, will be definitely 1:9. So 1 mole, so we can calculate easily. Molality is equals to 1 upon 9, which is the moles of ethanol. So the mass of ethanol will be 9 into 46 into 1000, right? On solving this, we will get 2.41, right? So this is very important question, in which when the phase is same, then how we can identify a solute and solvent has been mentioned. So the component which is present in more amount will act as a solvent, and which is in less amount will act as a solute. So it is not always essential that water will act as a solvent all time. In the next question, 40 milligram of MgO is dissolved in water to form 250 ml of solution of density this one. So simply again calculate the molality. 40 by 40 will be the moles of solute, and we can easily calculate the mass of solvent, because this is the mass of solution minus mass of solute into 1000. We can easily solve this and we can find out the answer. In this video, we have learned the relation of molality with the various concentration terms. In the next video, we will solve more problems and we will relate the other concentration terms, and we will find the shortcut or direct tricks to calculate all these concentration terms. Thank you very much.